All right, so again, the assessment will be on Thursday, or excuse me, on Friday. Again, we have late starts the next 2 days. All right. All right, draw angles in standard position. Determine values of trig functions of angles. So as we start to get towards working towards a unit circle in trigonometry, okay, we're interested in these reference angles. So most of this is stuff that I want to get to the diagram and show you. Here's what we'll be doing today. Angles in the standard position. The initial side is always your x-axis, okay? Straight up, up and down, that would form a 90. All the way over would be a straight angle, 180. We're gonna rotate all around in 270, so go all the way around, it is 360. So these angles will be kind of like a hand of a clock. We can move them, we can go around as many times as we want, each time changing the angle, but not where it's going from that spot. So the initial is always that. Think of this terminal side as the hand of a clock. Of course, it can go this way, which would be different from a clock, but also we can also have negative. So this guy is the terminal. He's going to rotate around wherever he wants in this kind of like a spinner, like twisters. Does it make sense to you? Okay? And these angles will all work within this circle, knowing it's 360. So we can also go negative with it. We're still starting on the positive x-axis. That would be a negative 45. This would be the terminal side that moves around. We're gonna have negative 180, 90, negative 270. Of course, we go all the way around, it would be what? Negative 360. So the key point really is that they all start on the positive x-axis, and then we're going to take one of the hands and we'll call that the terminal side. The terminal side is the side that's always going to be moving. 90 straight up, 180 straight over, 270 and 360. Let's draw a couple. Note taker's good here. Anybody still want some second on this one? Am I going backwards? I think I did. I'm gonna go this way. Thought it did. I'm probably messing myself up. Yeah, it was going the right way. Okay. So a little bit of art class this morning. Hopefully you like that. Draw an angle. We're drawing. Draw an angle in the standard position of a 45. Let's do this first one together. We're always going to start with your x and y coordinate. Sometimes it's helpful to label it 0, 90, 180, 270, all the way around, of course, is 360. And eventually you don't need to write that all out, okay? You do need to write an XY coordinate so you can see what you're doing there. Always starts where? On the initial, which is always the positive x-axis. And we're looking at a positive 45. Are we going to measure it? By no means. We're just going to take a guess. And there's your 45-degree angle. Make sense? Try this one. Doing some drawing today.
How do you do a negative one?
Starts where? Always starts where? Positive x-axis. Okay? That'd be negative what? 90? Somewhere around there would be negative 135.
So you go left when it's positive, right when it's negative?
You're pretty sure.
Thank you. Try to be.
Dr. Boss. Did you order that on the internet, by the way?
Yeah.
$210, see what you can do. Always starts here. $90, $180, and a little bit more. Again, we're not measuring, we're estimating 210. How do you feel about that skill? Is everybody okay? Nothing earth shattering there, is there? Now, these all have what we call co-terminal angles that go with them. They're 360 apart. So I'm gonna go the other way. If I come back this way, that'd be negative what? Anybody? Negative 315. So negative 315 and 45 share what? They share that terminal side. So if they share something, they're called co-terminal. Co-terminal angles are 360 degrees apart. 315 and 45, negative 315. Does that make sense? What would be the co-terminal here?
360.
Coming this way. Somebody take a guess? 225 is right. Co-terminals sharing this terminal side. How about this guy? It's gonna be negative though. See it? It's gonna be negative 150. Notice the distance between 210 and negative 150. What is it? 360. Okay? Co-terminal. Try another quick set.
We already did 210.
Yeah, skip 210. I know, I doubled that up. Skip 210.
Oh, you gotta go over.
Always starts here. This one's gonna go all the way around 360 and then up a little bit, 385. So we can go around. Now, eventually, what we're gonna talk about next is something called a reference angle. 385 is the angle, but the reference angle is this little guy right here. Reference angles always take the terminal side and the quickest way back to the x-axis. What would that reference angle be? The big angle is 385, but the reference angle would be 25.
See, like
285 minus 360 gives you 25. Make sense? What would be co-terminal? Coming this way to that 25, what would be co-terminal? Negative
335.
negative 335.
Yeah, that's what goes with that.
If I add 360 to 25, what do I get?
385.
Okay, so guess what? Co-terminal, co-terminal, co-terminal. How many co-terminals angles can I find with any terminal side?
3, 2.
How about infinite? Now all I gotta do is keep doing what? Adding? Adding what? What's a circle? Adding 360, add 360. I could go forever, couldn't I? How about if I could also subtract? I could also subtract what? But subtract 360, 360. Subtract, subtract, subtract. You get the same thing. All right, do negative 310 for all that.
300.
I'll look when I possibly. 300. Always starts here. That's negative 300, that'd be negative 90, negative 180, negative 270, negative 300. What's the reference angle for negative 300 though? It is 60.
That's literally Pac-Man.
It is 60, you see it? Everybody okay with reference? Reference angle, put this way back to the x-axis from the terminal. All right, coterminal, we just talked about that. When you think about coterminal, think what? 360, they share this terminal side, 120 and negative 240, they're 360 apart. Is everybody good with coterminals? How many can we find at each terminal? Infinite amount. Name me a couple coterminals. This is the only one we're gonna do, so grab your calculator if you want. This is simple, you can go forever, what do you gotta do? Plus and minus what?
360.
That's it. Just knock out a couple. Just get a quick little practice, holler one out, somebody. Anybody holler one out, you get there?
295.
Are you sure?
Negative 295.
Thank you, negative 295. Another one, 425.
I'm like that.
Are there more?
Yes.
Yes.
What else?
65. Negative 65.
No.
Logan, be quiet, so.
How are we getting these?
You got
Adding and subtracting 360 from 65.
How can there be infinite?
55.
Just keep adding 360.
Oh, negative 655.
Is that right? Negative 655? Okay. Plus 360 here, what am I gonna get?
785.
785.
830.
Keep going, no. Negative would be negative. Keep subtracting and adding, yeah.
1,000.
What's that?
1,145.
There you go.
1,500.
How many can you go for?
You can go all the way.
That's right.
So,
How many do you have to do?
Well, I just asked you for 102. All right, reference angle. I've already talked about this, but I just want you to look at it again. Reference angle in simplest layman form. What? Quickest way back to the x-axis. That's going to be a reference angle. Okay? Now my theta, my big angle there looks like, let's just say this blue one. What are you guessing? I'd guess about 120 degrees. Would you agree with me on that?
Yes.
Here's 90. Okay? So quickest way back to the x-axis is here, so my reference angle would be a 60. We okay with the reference angle? Everybody good? This was the easiest part of today. Let's get to the little bit more tricky stuff. It's not that hard, and you should be fine. All this stuff is just more of that. All right. 4-point XY coordinate. You're going to find sine, cosine, tangent, cosecant, secant, and cotangent. Here is the part that is a little bit harder today, but not ridiculous. Okay? So we're going to have the point x at 4, y at 3. We're going to graph that point. X is 4, 1, 2, 3, 4, y is 3, 1, 2, 3. Puts us somewhere in this neighborhood right here. Would you agree? I'm going to draw out a right triangle here. This leg is 3. This leg is 4, isn't it? I'm going to start thinking about this as a circle, because we're going to get into the unit circle. So this is basically a circle around here. If that's a circle, what is that guy right there? From the center? It is the radius, or the hypotenuse So your sine is gonna be equal to the y value over the radius. Now look, your reference angle is this guy right here, quickest way to the x-axis, right? So your sine is your y over your height, your radius, which is the same as your sine is your opposite over hypotenuse, okay? Your cosine is your x value over your radius, which is the same as your adjacent over hypotenuse. We're just changing a couple letters. Make sense, everyone? Your tangent is your y over your x, which is opposite over adjacent. There's your angle, your reference angle. Okay? So what's the first thing we gotta find? We gotta find that hypotenuse. How are we gonna find it? A squared plus a squared equals, find it, right now, find it. So we're gonna have 4 squared plus 3 squared equals our r squared, our hypotenuse. 16 plus 9 ends up being 25, so what is our radius there? 5. Now we're ready to do sine, cosine, tangent. See what you can do.
No, let's forget it all.
So if you got your reference angle, okay, you can still use SOHCAHTOA, or you know that the sine is your y value. The y value is what? 3 over my hypotenuse of 5. Cosine is 4 over 5. Tangent is 3 over 5.
Wait, you got 3 over 5 for 2 of them?
Wouldn't tangent through.
Tangent is 3 over 4. Thank you.
You're welcome.
Not often.
That's funny, isn't it?
See if you can get the other 3 trig values now. It should be pretty easy. Try it. Sine, cosine, tangent, cosecant, secant, and cotangent.
We do everything.
No, Mike.
All right, so what do we do when we just do what? Flip them, right? 5 over 3, 5 over 4. There's, what did we just find? Sine, cosine, tangent for what? A point on a Cartesian coordinate system.
Rene Descartes, that's the name, right?
Yeah, Rene Descartes came up with it.
Look at that. I remember.
Yeah, you remember that. It's all right. How we feeling here? Everybody okay?
Shut up. Shut up.
Call Danny.
All right, here you go. See what you can do. All radiuses are positive, so there's never going to be a negative. Now you can have a negative x or a negative y. In this case, we do. 1, 2, 3. 1, 2, 3, 4, 5, 6. Just somewhere up in here. -3, 6. There's your radius. -3 for your.
Wait.
You get that backwards.
Yep, I got it backwards. Never mind. Mr. Grubb having a wonderful bad day. All right, let's start again. 1, 2, 3, -3, 6 puts us right up here. How's that? A little better? Radius. There's your reference angle. Your y value is 6, your x value is -3. You gotta find your radius, your hypotenuse now. that hypotenuse or that radius is always gonna be a positive number. So it ends up being some things you have to rationalize, you have to do that. Anybody getting me a number? It'd be the square root of 45, right?
Yeah.
So square root of 45 does simplify. It is 9 times 5, so it's 3 radical 5. Okay, now try to find your sine, cosine, tangent. Sine is your y value, which is 6 over 3 radical 5. I'm gonna work on that. 6 over 3 is what? 2 over the square root of 5. Need to rationalize. So my full credit answer looks like that. 2 square roots of 5 over 5. I need to do the same with cosine, but what's it gonna be? What is my x value? -3 over 3 square roots of 5, which really simplifies to -1 over the square root of 5, does it? -3 over 3 there, right? Rationalize now. And end up with negative square root of 5 over 5. Tangent of our reference angle here is my y value over my x, or opposite adjacent, which would be 6 over -3, which is -2. Still hanging, this is it, folks, hang in there. I know some of you are beezing off on me, but hang in there, that's the last thing. Gotta find our next sine, cosine, tangent, cosecant, secant, and cotangent. Now, don't make yourself have a bunch of extra work here, okay? We simplified it right here before we rationalized, didn't we? So don't take it from this spot right here. Go back and just invert that. So it's gonna be square root of 5 over 2. That way I don't have to rationalize again. You see what I'm showing you? This would be just what? Negative square root of 5. If you wanna put it over 1, that's fine. Cotangent, we have -2, which would be what? -1/2. Here's the good news, that's all we're learning this week because of testing, right? We'll have the next couple days of practice before the assessment on Friday. Is everybody okay? That last part is probably the hardest part. You gotta find the 6 trig values given a point. Couple of odd problems there, nothing earth shattering. Thanks, everybody, for participating today.